Hello, everybody. So inside this problem, we're going to be getting a gauntlet of heat. So we're going to be tackling problems related to heat and thermal expansion. So here you have a very elementary problem. It's very plug and chug. So it's just asking you how much heat is required to raise the temperature of 34 kilograms of water from 15 degrees Celsius to 95 degrees Celsius. And under it, I've written that nice equation. And what this says is this gives you the amount of heat or the amount of energy that you, because heat is energy, this gives you the amount of heat that you need to put into an object or the heat required to raise an object of mass m and specific heat capacity C from some initial temperature Ti to some final temperature Tf. And just a distinction that I want to make between temperature and heat. The temperature depends on the physical state of a material, and it's a quantitative description of its hotness or coldness. So in physics, the term heat is always referred to as the energy in transit from one body or system to another because of the temperature difference, never to the amount of energy that's actually contained in that specific system. So that sounds like a mouthful, but just when we're talking about heat, we're always referring to, at least in this case, we're always referring to the energy in transit from one body to another because of the temperature difference. Okay? So we'll never use heat to refer to the amount of energy inside of a body. It's very important to make that distinction. It's something that I struggled with a lot when I found out about heat inside the physics course. What's the difference between heat and temperature? But definitely as we do more problems, the the definition or your intuition, it'll become clear. So how are we going to tackle this problem? It's plug and chug. We have all our variables. We know the mass, which is 34 kilograms. We know temperature final, which is 95 degrees Celsius. For the most part, you're going to be working in Celsius here, unless they specify otherwise. But the two most common temperature units would be Celsius and Kelvin in these problems. And the specific heat capacity of water is 4,190 joules per kilogram Celsius. This is going to depend on the temperature unit that you're using. So if you're using Celsius here, this should be Celsius. If you're using Kelvin here, which is a K, this should be a K here. So just entering all of this in. So this is 34 times 4,190 times this temperature difference. And the number that this gives me is a whopping 11,396,800 joules. And if I wanted to convert this, this would be 11.3968 megajoules. And for those who don't recall, this subscript mega just stands for a million. So this would represent 10 to the 6.